You can start, sir. I've started the streaming.
Yes, thank you, ma'am.
Yes.
Hello, students. Students, let's start with a new chapter today. Center of mass. There are a couple of model problems left in the last chapter, but we'll do it after center of, like while doing center of mass. Okay. Center of mass of system is nothing but statics. If we consider statics, particle in equilibrium, the point at which if this is at rest on a single point, that point from where all the forces are, or where the center of mass is nothing but just intuitively, all right, if we don't talk about force or anything, this point where it is at rest, or at which it is at rest, on which it is at rest, is center of mass. All right. Dynamically, if I throw this one in air, this will rotate about a point. All right. If I throw some rod, let's say rod in air, this will rotate about a point, right? And that point will translate. That point about which this object is rotating is intuitively center of mass. All right. If you don't have to locate center of mass intuitively, I'll just throw the object, not literally, uh, in air, the point where about which this seems to rotate. That's it. That is center of mass dynamically. But if you look at statics, the point at which, if it's at rest like this, on a fulcrum like this point is center of mass. All right. If we consider statics, intuitively it is this. Dynamics, it is this. Dynamics in sense, motion. All right. If we consider a particle in motion, the point about which the particle seems to rotate is center of mass. If I consider just the statics, this point is center of mass. The fulcrum point is center of mass of the object. But mathematically, how do you define center of masses? If I have a position vector of, this is origin, let's say there are n particles, or let's say two particles. This is R1 bar, R2 bar. This is mass M1, this is mass M2. This is center of mass of the particle M1 plus M2. Center of mass is nothing but M1 R1 bar plus M2 R2 bar by M1 plus M2. This is R bar, R naught bar. All right. When you do vectors in mathematics, you will understand it better, but we don't have to do that vectors to understand it now. It is all sigma MIRI, sigma MIRI by sigma M. You know what is sigma, right?
Yes, sir.
Yeah, yeah. But so sigma MIRI is M1x1, M1R1 plus M2R2 plus M2 M3R3, so on. If there are n particles, by sigma Mi, M1 plus M2 plus M3, so on till n particles, Mn. All right. This is for a discrete mass system. Discrete mass system means when you have masses as point masses, the different point masses, discrete point masses. But for a continuous mass distribution, sigma turns into an integral and it becomes sigma x dm by integral dm. This is my x naught. All right. Similarly for y naught and z naught. So my r bar becomes x naught I cap plus y naught j cap plus z naught k cap. We'll come to these applications in a while, but before that, let us apply for discrete mass system. Whenever you have a discrete mass system, it's sigma. For a continuous mass system, sigma transforms to an integral. So I've got masses like this. Or forget about the axis. We don't have an axis first. I've got a mass frame. Masses M naught on the vertices of a square. So symmetrically, intuitively, I can say that if I have a fulcrum, if I have got mass frame like this, if I have a fulcrum, that will be this frame will be at rest if I keep the fulcrum at the center of the frame, right? That's what intuitively it means, right? Because I've got mass. Able to see it clearly? Is it clear, students? Able to see this?
Yes, sir.
Yes, sir.
All right, good. Thank you. So let us find out position of the center of mass. Now, position with respect to this frame, center of mass is at certain place, right? But my x coordinate of the center of mass will depend on the origin. If I take the origin at, let's say, this point itself, center of the frame. So my center of mass coordinate should be 0, comma 0, comma 0. Because it's in xy plane, z is anyway 0. I'll have x and y to be also be 0. Let's find out whether do we really get it at 0 or not. Let the length of this will be 2a. So coordinate of m naught is a naught comma a naught. This is a naught comma minus a naught. This is minus a naught comma minus a naught. This is minus a naught comma a naught. So I'll have x coordinate to be x naught is equal to sigma mi xi by sigma m, which is nothing but sigma mi xi. Let's say this is 1, 1, 2, 3, and 4. So I'll have x naught is equal to m naught a naught plus m naught into a naught plus m naught into minus a naught plus m naught into minus a naught by 4m naught. Now look at this. This, and this get cancelled out. I'll get 0, which makes complete sense. Alright, I got center of mass position to be a 0. But if I were to take this as a coordinate, same with x naught, y naught. But if I were to take this as my origin, this is taken as origin before. We take this as origin. I'll have coordinate of this one would be 2a naught comma 2a naught, 2a naught comma 0, 0 comma 0, and this would be 0 comma 2a naught. Sorry, just a sec. Yeah. So x naught would be again sigma mxi by sigma m. So I'll have x naught is equal to, what am I supposed to get now? I'm supposed to get this point, right? Because I got center of the frame as center of mass. So I'm supposed to get a naught comma a naught as my center of mass. So let's see, do we get the same thing or not? So I'll have m1 m naught into 2a naught plus m2 m naught into 2a naught plus m3 m naught into 0 plus m naught into 0 by 4m. So what do I get now? 4 m naught a naught by 4 m naught gets cancelled out, 4 gets cancelled out, I'll get a naught. So I got x naught is equal to a naught. That's what I'm supposed to get logically. All right. See, we are now just trying to figure out that intuitively center of mass and also mathematically are they matching or not. But sometimes we cannot figure out intuitively. We can just figure out the region in which it is there, but we cannot spot the center of mass intuitively, exact point of the center of mass, exact coordinate of the center of mass. All right. So in that case, we'll resort to equations. And in this case, I'm just checking whether my uh, intuitive answer for the center of mass and mathematical answer for the center of mass are coinciding or not, or same or not. All right. So it makes sense. It makes complete sense now. Same for y naught. Y naught also I'll get it as a naught. So a naught comma a naught is my center of mass. All right. But now let us say I've got such 2m naught. Uh, yeah. Let's say this 2m naught. Instead of m naught, I've got 2m naught. In that case, what would happen? I'll have first point to be 1 to be 2m naught into 2a naught plus m naught into 2a naught plus m naught into 0 plus m naught into 0 by 4m. I'll get x coordinate to be 4 plus 6, 0, 0, 6 m naught a naught by 4 m naught, 5 m naught. What is the total mass now? Sigma m, m naught plus m naught plus m naught, 3 m naught, 4 m naught, 5 m naught. Sigma m is 5 m naught. So m naught gets cancelled out. 6a by 5 is my x naught. But look at this, I will not calculate y naught now because by symmetry, my center of mass should lie along this line. For m naught, center of mass was at this point. If I add additional mass over there, my center of mass gets shifted towards that mass by some amount. And I got center of mass to be somewhere here, which is 6a naught by 5, comma something. But by symmetry, x coordinate and y coordinate are same in here, 6a naught by 5. So I'll not calculate y coordinate. I just calculate the x coordinate and write both the coordinates. Is it okay? See, we are going a little unconventional. Okay, you can follow the textbook for examples, but I'm going a little unconventional in reasoning, which is very important to crack problems. All right. Now let us say, tell me the answer intuitively. Let us say I've got particle 1 and particle 3 to be 2m naught. If particle 1 is 2m naught and particle 3 is also 2m naught. In that case, where do you think the center of mass would lie? By symmetry, center of mass of these two would be at center. Center of mass of these two would be at center. So center of mass of the whole frame would be again at center by symmetry. Do you all agree? I'm supposed to get at center, right? A naught comma A naught is supposed to be the answer. Let's just check. Do we get the same answer or not? 2m naught A naught, 2m naught to A naught, 2m naught into 0 plus 2m naught into 0 by 6m naught. 4 plus 2 6. So this will be 6. M naught gets cancelled out, 6 gets cancelled out. I'll get A naught as the answer. So it again makes complete sense. The physical scenario and the mathematical answer are matching. Is it okay? Are you able to follow what I'm trying to say? If you're not able to follow, let me tell you. Let me tell you again. Okay, that's okay. You can ask me again. All right. But now, if I were to add 2m here, 2m, 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 and 2m, m. So where do you think the center of mass would shift? 2m, 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 and m. Where do you think the center of mass would shift? Symmetrically. And we'll have symmetric scenarios itself, students. In exam, in problems, we'll have symmetric scenarios mostly. If at all they are not symmetric, you'll not have mathematical aspect of it. All right, you'll not have to calculate mathematically. It'll again be logical. But if it is to be done mathematically, it will mostly be symmetrical. Not mostly, every time it will be symmetrical. Scenarios will be symmetrical in nature. All right, by symmetry, 2m naught, 2m naught, 2m naught, my center of mass will shift now along this line. All right, there are multiple ways of think about center of mass in this scenario, but I'm just telling you one way right now. As we go proceed in the chapter, you will understand the way number of multiple ways of thinking, the way I'm thinking when looking at such a problem. All right, I'll make you also think the way I'm thinking now, or perhaps you will think better. But you should be able to understand this problem from multiple ways. Okay, so center of mass will shift towards this point. Do you all agree? Because m naught was center, 2m naught, 2m naught again at center. If I just please add another mass over here, my center of mass will shift towards this diagonal. If I make this also 2m naught, it will again shift back to center. All right. Understand one thing. I have got m naught, m naught, m naught, m naught. That time I have it center. If I have it m naught, this has 2m naught. My center of mass will shift towards that mass diagonally along this direction. All right. So we got some answer. We got 6a naught by 5, comma 6a naught by 5. And why is x coordinate, y coordinate same? Because along the diagonal. Square cut diagonal makes 45 degrees with the x-axis. This is my origin. It is along this y is equal to x line. All right. Okay. Now, if this is 2m naught and this is 2m naught, my center of mass will again lie at center by symmetry. If these three are 2m naught, my center of mass will be shifted towards this diagonal. If this is also 2m naught, all are 2m naught, center of mass will again lie at center. All right. I'm just trying to convince you by the argument of based on symmetry. Sorry. Based on symmetry, I'm trying to convince you where the center of mass shifts and how much is the shift. We'll calculate mathematically, but we should be able to guess the shift towards which center of mass is going to lie. I mean, region in which center of mass is going to lie. All right. All right. Now, center of mass is for a discrete particles, but center of mass for a planar region. Students, either it will be symmetric in nature, or if you have a discrete system, you will be able to calculate mathematically. But if at all you have to reduce the number of steps or more logical kind of a question, the question scenario will be symmetrical. All right. If it is not symmetrical, that means either you have to calculate mathematically completely the answer, or logically you will be able to you will be able to spot the region in which the center of mass lies, but you cannot exactly tell you which we cannot exactly spot the center of a coordinates of the center of mass intuitively. Remember that. You cannot exactly spot the coordinates of the center of mass intuitively always. Only in the case of symmetric situations, perfectly symmetric situations, you can say that center of mass lies at center. For instance, I've got a planar region, a rectangle of surface mass density sigma naught. Its center of mass lies at center. All right. There is another circle. This is, let's say, sigma naught, sigma 2, and this sigma 1. Then this center of mass lies at center. Center of mass of both will lie somewhere between these two lines, between these 2 points. Right? It will lie within these 2 points. This is the region where center of mass lies. If this is the midpoint of this one, if the mass of this one is heavier, it will lie towards this point. If mass of this is heavier, it will lie towards this point. All right. Now let the radius be r and this length be 2r. And let this length be 3r. Let this length be 2r. Or let's take it's a square initially. Doesn't matter, square or rectangle. Center of mass is at center. All right. Now I have to spot center of mass. Intuitively, I can say that logically I can say the center of mass lies between these 2 points. Now, intuitively, I can say that if this is heavier, my center of mass lies towards this point, towards this center. If this is heavier than this, center of mass of this planar systems, two planar bodies, center of mass of this system, which consists of two planar bodies, lies more towards this point, if this is heavier than this. All right. If both are equal in mass, center of mass exactly lies at the center. Midpoint of these 2 points, these two centers. So let's locate the center of mass of this two particle, not two particle, system of two planar bodies. See, I can treat this whole mass to be present at this point. I can treat this whole mass to be present at this point. That's the very definition of center of mass. Center of mass is nothing but a point at which I can treat whole mass to be concentrated at that point. So center of mass of this one is at this point. So let's say mass of this is M2. Mass of this is M1. So I'll have, if I take this as origin, this distance is how much? Can you tell me what the distance is? 2r, and this is r. Center is r, r, r naught and r naught. So what is the distance of M1 from origin? M1 into 2r naught plus M2 into 0 by M1 plus M2 is my x naught. All I have to do is now find out M1 and M2 in terms of sigma and sigma 2 and plug in M1 and M2 here. For convenience, for calculating, so sigma gets cancelled out. Let it be sigma naught and sigma naught. All right. Let that be made of the same material. Sigma naught is nothing but surface mass density. So mass per unit area is sigma naught. So total mass will be sigma naught into area. What is the area of a square here? sigma naught into area of a square is 4r square into 2r naught plus m2. What is the area of this? Anyway, into 0, but let's write the mass as well. Sigma into pi r square into 0 by sigma into 4r square plus sigma into pi r square. What I now get is, this is anyway 0 gone. So I'll have sigma naught into 8r cube by sigma naught times sigma naught r square times 4 plus pi. Sigma gets cancelled out, r square gets cancelled out. I'll have 8r naught by 4 plus pi. Is the coordinate of the center of mass. What is the y coordinate of the center of mass, students? By symmetry, it is 0 because this is my y-axis. X-axis. Look at this. It is lying symmetrically on the x-axis. So my y coordinate of the center of mass is 0. So my coordinate of the center of mass would be 8r by 4 plus pi, comma 0. Just check if this is correct, students. 8r by 4 plus pi. I could be wrong in this. Is it correct? Students, is it correct? 8r by 4 plus pi, is it correct? Students, just check whether this step is correct or not. Till here it's fine, perfect. But after this, from here to here, is it correct or not? This step to this step. Do we get 8r by 4 plus pi? If you haven't followed, I'll do it again. All I'm doing is mathematically finding out the position of center of mass. And intuitively, I could judge that center of mass lies between these 2 points. And I have to spot it exactly, the coordinates of the center of mass, I'm doing it mathematically. And y coordinate is anyway 0, so I'll not calculate y coordinate at all. All right. Now, students, are you all there? Now, let us say this is sigma 1 and sigma 2. Sigma 1, sigma 2. I have to find the relation between sigma and sigma 2 such that my center of mass lies exactly at center. Center of mass should lie at this point, at the point of contact, which is at center of these 2 points, M1 and M2. R0 and R0, 2R0, midpoint of that is this point. So my center of mass to be at that point, that means my x0 should be equal to R0. All I have to do is plug in M1 and M2 in terms of sigma and sigma 2 and equate it to R0. We'll get relation between sigma and sigma 2. Let's see we'll get the right relation or not. And I mean, see, they cannot be equal. They have masses have to be equal, but because areas are not equal, then masses will not be equal because sigma and sigma 2 are not same. If sigma and sigma 2 are same, my areas have to be same. But areas are not same here. This is 4r square, this is pi r square. So if areas are not same, my sigma and sigma 2 also should be different. For that, masses should be same. Confusing? I confused you? No problem. I'll do it again. I'll not confuse you again. I'll just solve the problem again. Okay. So M1, which is yeah, substitute M1 here. Shouldn't substitute M2 as pi r square, that's anyway 0. So M1 would be sigma 1 into 4r square into 2r equal to, now look at the students. If I take this as origin, alright, I'll simplify it further because I know the location of center of mass. I'll take that as origin. So that will be equal to, my center of mass should be at origin. That means my x naught should be equal to 0. So in that case, my coordinates will be m1 into r naught plus m2 into minus r naught. Because if this is my origin, this is r naught comma 0, this is minus r naught comma 0. Equal to 0, this goes to the right, 0. So what I get is m1 is equal to m2. What is m1? What is m1? Sigma 1 into 4r square should be equal to m2. Sigma 2 into pi r naught square. So r naught square gets cancelled out and have sigma 1 by sigma 2 is equal to 1 by 4 pi. Sorry, pi by 4. Check if this is correct. Have you understood this point? Have you understood this physics of the problem? It is m1. Why am I equating m1 to m2? Because m1 r1 plus m2 into minus r1 minus r naught is equal to 0. So this goes to the right hand side again. R naught gets cancelled out. M1 is equal to m2. What is m1? Sigma into area. Sigma into area. Sigma 1 into area of the square. Sigma 2 into area of the circle. So sigma 1 is equal to sigma into 4 r square is equal to sigma 2 into pi r square. R square gets cancelled out. Sigma 1 by sigma 2 is pi by 4. So I got the relation between sigmas, surface mass densities of two planar bodies, such that their center of mass lies at the point of contact of the two bodies, two planar regions. All right. Is it okay, students? Is this point clear? Center of mass, this whole chapter revolves around this equation. That's it. And this whole concept, center of mass, positional center of mass, locating center of mass revolves around this concept. Once you are comfortable with applying this formula to any region, any configuration, you're done with whole chapter of center of mass. You'll have additional concepts of momentum and all, conservation of momentum and all, but that's fine. Uh, they become intuitive if this becomes intuitive. If the concept of center of mass becomes intuitive, those concepts also become intuitive. All right. Now, let us say instead of this, now there's a classic problem. All right. Let's say instead of this another square plate, I've got circle of radius r naught, on which there's another circle of same sigma, same surface mass density sigma naught, is kept on this circle. So this is one circle on which this another circle is kept. Another planar region, thin planar region is kept. See, whenever I talk of sigma, it means they were very thin. All right. If they were not thin, I would talk of rho. All right. I would talk of volume mass density. But because they are thin regions, I'll talk of surface mass density. All right. Now, okay, look at this. I have to find out the center of mass of this two bodies, two planar regions. So center of mass of this one would be at center, which is over here. Center of mass of this one would be at the center, which is the distance of r by 2 from here. Now center of mass will lie along this line. So I will take my coordinate to be along this point. I have to spot the center of mass. If the origin is not given, you are free to take the origin. But all I have to do is find the position of find the position of center of mass for this configuration means spotting the center of mass with respect to certain coordinate system. So with respect to certain origin, I will spot the center of mass. Center of mass of this one lies at R naught, so let that be M2. Center of mass of this one lies at origin, let that be M1. This bigger one be M1, smaller one be M2. So my X naught is equal to, let's say this is my center of mass. Actually, where do you think the center of mass will be shifted towards? Both are same sigma. This area is lesser, so M2 is less than M1. If 2 points have got M1, M2, if M1 is heavier than M2, my center of mass will be shifted more towards M1. If this is the midpoint, center of mass will lie at the midpoint if M1 is equal to M2. If M2 is more than M1, it will lie towards more towards M2, shift more towards M2. If M1 is greater than M2, it will shift towards M1. Now, what is heavier here? M1 is heavier. So my center of mass will lie along this line and shifting more towards M1. That's the common sense says, right? We should get the answer also to be less than R by 4. Because this is R by 2, my answer should be less than R by 4. If answer is not less than R by 4, there's something wrong with your calculation. Alright, there's a small check. Alright, that's kind of small verification. After you get the answer, your answer should be less than R by 4. Alright, or if you have multiple options and all options are more than R by 4 and only one option is less than R by 4, that's the answer. You don't even have to calculate. See, ultimately, students, it's all about cracking the problem in exam, for which your concepts have to be strong. Your practice has to be intense. All right. Now I'll write M1 into 0 plus M2 into R naught by 2 by M1 plus M2 is my X naught, which logically has to be less than R naught by 4. All right, that's just a check. So M1 is how much? Anyway, it is going to be 0, but I'm just still writing pi R square into 0 plus M2 sigma naught into pi R naught by 2 whole square into R naught by 2 by M1 plus M2. What is M1? This much. Sigma naught into pi R naught square plus M2. Sigma naught into pi R naught square by 4. So this is anyway 0. Sigma into pi, sigma into pi, sigma into pi gets cancelled out. R square, 1 R square gets cancelled out. So I'll have, so this 4 also gets cancelled out after taking LCM. Pi, 4 plus 1 is 5, R naught by A, R naught by 10. Just check if this is correct. Is it R naught by 10? Because there was no space, I've deleted here itself. Erase the quantity here itself. But check if this is R naught by 10. Students, are you all there? Ashni, Ashrita, Gayatri, Shivani, Amini.
Yes,
Yes,
sir.
sir.
Can you just tell me if this is R by 10? Yeah, is it fine? All I'm asking you is if this is R by 10 or not. Say something here.
Yes, sir.
Is it R by 10?
Yes. Yes, sir.
Okay. So R by 10, look at this, R by 10 is less than R by 4. So our answer is in agreement with our common sense logic, right? That was less than R by 4. My center of mass is supposed to be less than R by 4 because this is heavier than this. So center of mass will lie more towards M1. So my x naught is lying at x naught by R naught by 10, which is making sense because it's less than R by 4. All right. If it were R naught by 8 also, it would make sense, but it would be a contradiction. It would be if it were to be R by 3 or R by 2. All right. Okay. Now next case is a case where instead of keeping an additional mass on this one, I remove this mass from this larger plate. I cut this section of the larger plate, a circular section of the larger plate. Now, how do we find center of mass is the question. This is a classic problem where we introduce a mathematical artifact. All right, it's called a mathematical artifact. I'll tell you what it is. But where we introduce the concept of negative mass. All right, it doesn't exist, but we just mathematically introduce a mass over there, which turns out to be negative in nature, negative in sign, and we say that's a negative mass. All right, I'll tell you what it is. Look at this. What's happening is now this is my region. All right. Now this is my mass. Look at this. What I do, I fill this with now this is sigma naught. All right. Density of this is sigma naught. What I do, I fill this with hypothetically, I fill the cavity, I fill the vacancy over here with sigma naught and minus sigma naught. Mathematically. All right. We don't have minus sigma at all. It doesn't exist. But if I fill it with sigma and minus sigma, they cancel each other and there will be a cavity itself. This is a vacant space, mass is zero. If I introduce mass of sigma, region of plate of density sigma naught, it will become a circular plate on which I've overlapped another mass of density minus sigma naught. So this becomes a problem of this one minus this one, or this one plus or minus this one. Center of mass of this I know as center. Center of mass of this I know as center. I'll do it as I've done before. Same. I'll do the same problem as I've done the same previous problem, with the only difference that sigma naught is going to be minus sigma naught in this case. What I mean to say is, when I fill it with sigma and minus sigma, it is same as zero. If it is 0, now this system of total sigma and minus sigma is nothing but this is equal to total as sigma plus overlapped with a disk of minus sigma. So I write the equations here. Center of mass of this whole bigger one would be at center, at origin. And common sense says, if I remove this mass, my center of mass will shift towards this line of symmetry, somewhere here. So my center of mass is supposed to be negative. If this is my origin, my center of mass should turn out to be negative. It cannot be positive or it cannot have y or z coordinate. It should have x coordinate which is going to be negative because my center of axis is taken along the axis of symmetry of this region. Again, symmetry. I've taken the x-axis to be along the axis of symmetry of this region. If this is the origin, my center of mass will shift towards this one. If this were there, my center of mass is at origin. If this were filled with sigma naught, one complete disk, bigger disk. But because I've removed this part, my center of mass will shift towards the heavier region, away from the lighter region. So my sigma x naught would be, as I check, it should be negative. X naught would be m1. Let's say this is m1, this cavity is m2, or this is m2. Cavity has got no mass. m1 plus m1 into 0 plus m2 into r naught by 2 by m1 plus m2. But what is m2 now? It is minus sigma naught into pi r square, pi r by 2 whole square. So this is pi r square into sigma naught into 0, anyway 0, plus sigma naught into pi r by 2 whole square into r by 2, but this is minus sigma here by total mass. m1 is how much? Sigma into pi r square plus minus sigma into pi r by 2 square. Again minus over here, plus times minus is minus. Alright, can you now simplify this? This is anyway 0 gone. Sigma gets cancelled out, pi gets cancelled out, r naught square gets cancelled out. Can you further simplify this and tell me the answer? Your answer should be negative. Can you simplify this please and tell me what's the answer? If you don't simplify, I'll go ahead. Supposed to be 3, 3. Sigma is cancelled out, pi is cancelled out, r square is cancelled out, 1 by 4, 1 by 4, 4, 0, 3, r by 6, r naught by 6, minus r naught by 6. Minus r naught by 6 is the answer. Check if it is correct or not.
Yes, sir.
Is it correct? All right. Let's go for the next level. Students, you're not responding. What do I do? Do I skip or do I go ahead? All right. Anyways. All right. Now let's look at the continuous mass distribution now. For a continuous mass distribution, I told you integral x dm by integral dm. But for simplest case, let's take a rod of linear mass density lambda, or mass is m, length is L, m by L is lambda. All right, linear mass density is mass per unit length. Now look at this. My center of mass should be at center intuitively, because it's where, if I keep a fulcrum, this will be at rest, because symmetric body, uniform body. So this mass, symmetrically, it should be at center. Center of mass should be at center. That's the point where whole of the mass seems to be concentrated. That's again a little technical, but more intuitive is, if I keep a fulcrum here, that will be at rest when I keep the fulcrum at L by 2, at center of the rod. So let's choose an origin with respect to which we will calculate the center of mass. If I take this as origin, first case we'll take this as origin, second case we'll take this as origin. All right. In both the cases, I'm supposed to get the same center of mass position. In the first case, what am I supposed to get center of mass as? L by 2. In the second case, I'm supposed to get 0, because my origin is at center of mass itself. All right. So let's figure out, do we get the same answer or not? In the first case, what I do, I chop this, in both the cases, I chop this into infinite number of infinitesimal pieces. At a distance of x, I consider dx. Mass of this would be lambda dx. So dm is equal to lambda dx. My equation for center of mass is integral x dm by integral dm. This is my x naught, which is supposed to be L by 2. I know that. So we are just checking it's going to be L by 2 or not. All right. Is our math correct or not? So it is x dm. X dm is lambda dx by integral lambda dx. Integral dm is nothing but m. So I don't have to do this integral. I can directly write m here. But what are the limits of the, see, we'll have definite integrals itself in physics. So what are the limits of the integral? It goes from 0 to L, which is nothing but integral x dx would be, integral x dx is how much? Students, you're all not there today.
Sir, x square by 2, sir. X
Okay.
square by 2.
Who is it, Bhavna?
Yes, sir.
Where were you, Bhavna, from morning? You joined late, huh?
Sir, I had some network issues, sir.
Okay, no
Now
problem.
it's fine, sir.
Sorry?
Sir, it's fine now, the network issue.
Okay. Good. All right. So x square by 2 into lambda under limits 0 to L. So L square by 2 into lambda. Lambda into L is M. That gets cancelled out. I'll get L by 2. And that's what my answer is supposed to be, L by 2. Now I will tell you how the limits have done. Limits have substituted. See, my limits go from wherever my x is ranging from. I have to cover this x from whole of the mass. 0 to L. Because my x is starting from 0. Mass is starting from 0. So x goes from 0 to mass is ending at L. So it goes from 0 to L. Right? Now let us do the same thing with this as origin. So at distance x, I consider dx. Everything will be the same. Whole equation will be the same, except the limits now. Limits will now be my x is ranging from this point to this point. This is my origin. This point is L naught by 2, sorry, L by 2, and this point is L by 2, comma 0. So my limits will now be L by 2 to L by 2, L by 2 to L by 2, L by 2 to L by 2, and M is nothing but lambda L. I'll write it as lambda L itself because lambda gets cancelled out eventually. All right. Now what do I get? I'm supposed to now get 0, right? So L by 2 whole square minus L by 2 whole square into lambda by lambda L, which is nothing but 0. And answer is 0 because my center of mass is at origin. So that makes complete sense. I don't even have to go further than this. Look at this, student. I don't even have to go further than this. I have got an odd function here. X is an odd function. It is going from minus L by 2 to L by 2. Minus L by 2 to L by 2. For an odd function, area under the graph is 0 under symmetric limits. So I don't even have to go further. I can directly write 0. Alright, which is matching with our intuitive conclusion that center of mass is at center of the rod, origin. If I were to take the origin to be here at a distance of x1 from this point, my integration limit should be x1 to x1 plus L. Okay,
Yes, sir.
now let's consider a rod. Right. For considering another rod of variable mass density, let us consider a circular arc or semicircular arc of uniform density, uniform linear mass density. This is my origin. Alright. Now I have to find out the center of mass of this structure, this frame, semicircular frame. Center of mass will obviously lie along the line of symmetry, along this line. So I'll take my x-axis to be along that line so that my y-coordinate is 0 and that will be not at origin but it will shift it towards this line. If this were complete, I would have at origin, but this is removed. So some mass is removed from here. So my center of mass will shift towards the heavier part, heavier region. So center of mass will move towards right. Alright, so my answer should lie between 0 to R. And this result is very important. You have to remember this result. Alright. Now what I do, again, I chop this into infinite number of individual pieces. I write m1 x1 plus m2 x2 so on by sigma m. But because it's a continuous mass distribution, I told you sigma transforms to integral. So at an angle theta, if I take at an angle theta, if I consider a small element of length r d theta, So x coordinate of that is r cos theta, y coordinate of that is r sin theta. Y coordinate is anyway 0. We don't have to bother about it. But x coordinate is r cos theta. So lambda integral x dm by integral dm, where x coordinate is center of mass of that element. Now that I'm treating this as point particle, this r d theta is being treated as point particle. So r cos theta into dm. What is the dm of that? Lambda r d theta by integral dm. Integral lambda r d theta from now where the limits are supposed to be now. My limits are supposed to be, this is going from 0 to pi by 2, and it's going from 0 to minus pi by 2. My mass is going from minus pi by 2 to plus pi by 2. So my limits are going to be minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. That's it. All you have to do is integrate. Integrate cos theta now. Lambda r gets cancelled out. Integral cos theta d theta is, what is integral cos? What is
That
integral
is
cos?
minus sign, sir.
No. Derivative of cos is minus sign.
Yes, sir.
Integral cos is sign. Okay, look at this. I'll get r naught sin theta from limits minus 5 d theta, sorry. Minus 5 to pi by 2 by pi. Why is it pi? Minus 5 to pi by 2 d theta is pi. Okay, now that is equal to r naught by pi integral minus pi by 2 to pi by 2 sin theta d theta. Oh, sorry, why did I write integral again? It's under limits minus pi by 2 to pi by 2. So what is it? 2. So answer is 2 r by pi. And this is what you have to remember. There are certain configurations which you have to remember. With practice, you can remember. Okay. But with practice, you can remember. So answer is 2r by pi comma 0. My distance from origin is 2r by pi. ఇక్కడ నుంచి ఎంత అవుతుంది? r minus 2r by pi. Somewhere here. Alright. Is it okay? Or do you want me to do it again? All I've done is integral x dm by integral dm, where x is the position of coordinate, so coordinate center of x coordinate center of mass of that element. I'm treating that element to be a point particle. So integral x dm. Dm into lambda r d theta. Because lambda into length limit give me dm. Lambda r d theta is my dm. Alright. Is it okay? Should I go for
Yes,
the
sir.
next one?
Yes,
Okay.
sir.
Yes, sir.
Okay. I'll go for the next one now. Where I'll take this to be subtending an angle of theta. This arc is semicircular arc now. But now in this case, it's not going to be semicircular arc. Rather, it's going to be an arc which is subtending an angle of theta at the center. Theta naught at the center or alpha naught. Some angle theta naught. Let's say theta naught. But I'll do the same thing again. I'll have x cos x dm by integral dm. Only change would be my limits would change. And my limits would be from minus theta by 2 to theta by 2. Everything remains the same except the limits. Everything remains the same except the limit, students.
Yes, sir.
Hmm. So what do we get? 2r sin theta by theta. Right? Find out. What do you get? This is theta. At the denominator, I've got theta naught. You want to write it again? I'll write it again. Now look at the students. I've got y coordinate to be 0. It makes complete sense because I've taken the line of symmetry to be my x-axis. Right? ఇలా ఆర్క్ ఉంటే this subtending angle of theta naught, my angle of line of symmetry is this one. If I take x-axis to be along this line, my y coordinate is 0. But mathematically చూస్తే ఎలా రావాలి మనకి? This should be r sin theta into dm by integral dm, right? R sin theta integral dm by, I mean integral r sin theta dm by integral dm. ఇది చూడగానే 0 చెప్పొచ్చు. ఎలా చెప్పొచ్చు? It's between symmetric limits and odd function. Odd function is under symmetric limits is 0. So numerator is 0, 1. So y coordinate is definitely 0. That we have intuitively concluded because it is got symmetry. Symmetry valla it will be along the line of symmetry. Center of mass lies along the line of symmetry. If I take x-axis to be along the line of symmetry, my y coordinate is 0. But mathematically choosing kuda, my y coordinate is turning out to be 0 because I don't even have to calculate integral sin theta choosing integral sin theta. Oh, sorry. It's sin theta. Ne? Integral sin theta choosing and further calculation also because integral sin theta is between its symmetrical limits is 0. Alright. So odd function choosing symmetric limits చూడగానే 0 పెట్టేయాలి. Alright, you should not go further, you should save your time. Alright, let's go further now with another linear mass density with a variable linear mass density. Then we'll go for surface mass density and come to it tomorrow. It's a matter of 15 minutes. But linear, this is a little critical problem mathematically. Otherwise, intuitively it's fine. I've got a mass, a rod, whose density is varying from this end like this. Density is going on decreasing as lambda is equal to lambda naught e power minus x by L. My lambda is varying like this. That means at x is equal to 0, it's lambda naught. As I go further, it's going on decreasing. At every L, my lambda, it is becoming lambda by E. Alright. This function is very important in our physics. Oh, you're not able to see the function at all and you're not seeing it.
Sir, it's not visible.
Okay. I'll write it down. You put visible now?
Yes, sir.
Okay. Now, center of mass, and this is an infinite rod. Alright. Infinite rod తీసుకోవాలా లేకపోతే finite rod తీసుకోవాలా? You tell me. What do I take?
Infinite is
Infinite తీసుకోవాలా? Alright. Okay, I'll take infinite rod. This is actually a previous Olympiad question where he asked, where should I keep the fulcrum such that it should be at rest? Fulcrum ekkada pedte this should be at rest. That means indirectly is asking where should the center of mass be? Where is the center of mass is going to be? Alright, fulcrum ekkada pedte it will be at rest. But it is interestingly, infinite unna kuda, there is one particular position of center of mass. Alright, that's what you have to find out. Alright, infinite unte, sir, infinite kada, infinite unte, my center of mass can be going on shifting towards right కదా అని అనుకుంటారు. No. Center of mass is going to be at one certain fixed position from this end. ఇక్కడ నుంచి మళ్ళీ కట్ చేశాను అనుకోండి, ఇక్కడ వరకు కట్ చేశాను అనుకోండి, my center of mass will again lie at same distance from this end. మళ్ళీ ఇక్కడ కట్ చేశాను అనుకోండి, my center of mass will again lie at same distance from this end, left hand. So this is an interesting problem. I'll just frame the equation today. You try this, you think about this problem. If you want, you can solve it. But we will not solve it in BPC classes also. So I'll just frame the equation now, which is very important. Solution is mathematical, which we'll do it only in specific MPC classes. All right. And deeper analysis, Olympiad level analysis, tarvata cheddam. But right now, we'll just go for the concept, which is common for Neet, mains, and advanced. All right, I'll take this as origin and a distance of x. I chop this into infinite number of infinitesimal pieces, lambda dx. So my equation would be integral x dm by integral dm is my x naught. X naught turns out to be interesting value, all right, but I'm just telling you how to do it. So integral x dm. What is dm now? Lambda dx, which is lambda naught into e power minus x by L naught dx by integral dm. dm is lambda naught into e power minus x by L naught dx. Now limits. What do you think the limit should be? My limit should range, should cover whole of the mass. Limits are nothing but the coordinates of x covering whole of the mass. My coordinate x starts from origin, so 0. It goes till infinity. See, exact framing of the problem was not that simple. I say it's an Olympiad problem. So exact framing of the problem was not that simple. All right, it was something else. All right, we'll discuss only in MPC class. But right now, just understand that I'm finding out center of mass of a rod with non-uniform linear mass density. All right. Okay, so lambda gets cancelled out. I have to integrate all this and then get the answer. In integrate chesi answer techukogaltara. I'll tell you the integral also, so that you don't have to face difficulty in evaluating the integral. Lambda naught బయటకు వచ్చేస్తుంది. Okay. Evaluation of integral is really complicated. I mean, it requires product rule for integration. We will not do it now, but this is how you frame the integral. Integral x dm by integral dm. All right. And dm limits same ఉంటాయి integral dm లో. Integral limits same ఉంటాయి integral dm లో. It goes from 0 to infinity. 0 to infinity. Why is it going from 0 to infinity? Because my mass starts from 0 and it tends to infinity. It goes to infinity. Infinity is nothing but if I say this L length constant over here, I told you it's a length constant, e power minus x by L, that's nothing but length constant or time constant. X and x terms lo unte length constant. If that length constant is very less compared to the length of the rod, then I say it's infinite. All right. Anyways, we'll stop here. Students, have you all understood? Because you have been, I mean, most of you joined late. At the beginning of the session, only very few students were there. Even now there are few, but only 3 students were there initially, Gayatri, Ashrita, and Hashini. But I don't think you have understood everything. So you please go to the beginning of the lecture. It's very intuitive, so that next class becomes very easy for me. All right, next class I'm going to gear up speed. Inka MPC class in తీసుకుంటాను extra class. All right, if possible, in the evening, because only MPC students will be available in the evening. There we'll do some Olympiad problems. But that's not the point now. The point is, are you comfortable with the intuitive understanding of center of mass or not? Intuitive understanding of center of mass, beginning of the session lo cheppanu. Adi comfortable aithe your whole chapter becomes easy. All right, students. So thank you all. See you tomorrow. Bye, everyone.